Before we begin this section of adding some more steps and different things to our linear equations, I'm going to review one more two-step equation. Now it's really important that you learn the proper steps in solving an equation. You may be able to look at a lot of the first or the one-step and two-step equations and come up with an answer without solving it. The problem is, in math land, the numbers and the equations are not always going to be that easy. It's really important to be able to have the skills, the proper steps and procedures to solving it for when you don't have questions that are so easy to look at and know the answer to. That's why we learn the procedure. So make sure that you take the time to learn the proper steps so that you can use those same skills when we get to bigger and uglier equations. Okay. Once again, here we have a two-step equation. We know it's a two-step equation because we have this negative 5x. Remember, that's a negative in front, not a subtraction sign. There's nothing between the number and the letter, so we know that that's multiplication. Negative 5x plus 6 is equal to 16. So we have the multiplication and addition on one side of the equal sign, and just a single value on the right side of the equal sign. Once again, our goal is to get the variable by itself. Now the first thing we do is we get the term that has the variable by itself. That's the negative 5x. It's okay that there's a number right next to the x at this point. We want to get all the other stuff away from it. Then we'll worry about dividing and conquering. So in this problem we are adding 6. To cancel out adding 6 we have to take away or subtract 6. Once again, whatever I do to one side of the equal sign, I have to do the same thing to the other side to keep it balanced. We now have just our negative 5x on that side. 6 minus 6 is 0. And on the right side, 16 minus 6 gives us 10. Now we have this multiplication that we have to undo. So in order to do that, we once again divide. Now whenever you multiply or divide, you keep the sign of the number in front because we want to find out a positive x. And two of the same sign when multiplying or dividing is a good thing, meaning it gives you a positive answer. So again, whatever you do to one side, you do the other side. Any number, negative 5, divided by itself, negative 5, is a positive 1. That's another way of looking at that to give us a 1 times x, but 1 times x is simply x. No, there's no minus sign in here. I'm just canceling these out and leaving a 1 behind. We have the tendency to think that when we cancel we get 0, but that's not true. There's always a remnant left over. On the right side I have a positive divided by a negative. When we're multiplying and dividing and we have mismatch signs, that's a bad thing, so the answer is going to be negative. Now be very careful. On a problem like this, we have the tendency to go a little bit too quickly. Talk it out loud and say the operation. It's 10 divided by negative 5, not 10 minus 5. So the answer here is not 5, but a negative 2. Make sure that you review those things and work it through slowly. As always, I would strongly suggest that you go through and you put your answer back into your original problem. You don't necessarily need to show that on your homework, but it's a good practice to always do. Check your answers. Make sure that you're doing it right. Now, let's change things up a little bit. Let's add another step in here. What if we had 2m minus 3 minus 8m is equal to negative 27. Now we need to identify what's different on this problem than our other problems so that we know what we might have to do to simplify it. Now what I notice on this problem is I have two variables or two terms with the variable m in it. Now I have a total of 1, 2, 3, 4 terms in this problem. But two of the terms are like terms on the same side of the equal sign. If they're on the same side of the equal sign, we do not switch anything with their signs. We simply combine like terms like we would if this was an expression. So in this case, it's 2m minus 8m. 2m take away 8m would leave me with negative 6m. Once again, those terms are on the same side. This is a negative because the sign in front of the term goes with the term. So we'd have negative 6m. Now I didn't do anything with the minus 3, so that comes along for the ride. Still have our equal sign, and now we have the negative 27 on the right side. Now our problem looks just like the previous one. We have a two-step problem. The first step is to get all of my like terms together on opposite sides from their unlike terms. So the term with the m, since these don't have m's, is the unlike term. We want to get that away and keep the ones that don't have the variable together on the other side of the equal sign. So in this problem, I need to cancel out the subtracting 3. We always switch signs when we move terms. Terms are the stuff that's added or subtracted. So I have to move it over by adding 3. That leaves us with a negative 6m on this side is equal to. Now on the right side I have a negative number and a positive number. When we have one of each sign, we subtract the two numbers and keep the sign of the number that's further from 0. In this case, 27 is a whole lot further from 0 than 3. So the sign on the 27 is negative, so the sign on my answer here is negative. Now we continue on, and we get m by itself by canceling out the multiplication. Once again, this is not subtraction because the horizontal bar is not between the number and the letter. It's out front. So this is saying negative 6 times m. To undo multiplication, we divide. The sign goes with when you multiply or divide. So we get m is equal to, once again here, multiplying and dividing, same signs is a good thing, so that ends up being positive. Always check your answers. Replace, go back into the original equation, replace all of your m's with 4 and simplify. The left side should equal the right side when you use your order of operations. So if we have terms on the same side of the equal sign, you'd have to combine them first before solving your equation. Let's look at one that's fairly similar and see if there's a difference to it or not. Let's try a problem like 2x minus 7 is equal to 3x plus 4. Now in this problem, we also have two terms with the variable and two terms without the variable. But here we should notice that the difference is that the terms with the variables are also on opposite sides of the equal sign. On our previous problem, they were on the same side of the equal sign. Here, they're on opposite sides. So in order to gather them, we have to move across the bridge, or that equal sign. Whenever we move across the bridge, that's when we switch our order of operations. That's when we do the opposite to add it to the other side or subtract it. We're not going to do same signs. Now there's two steps that we could have done for this one. We can move the variable term always to the left. I know a lot of students like to do that. Just always have the variable on the left side and the numbers on the right side and go from there. That's fine, but in order to do that in this problem, we would have to take away, since we're moving the whole term, that's when adding or subtracting happens, it's a positive 3x because the sign in front of the term goes with the term. There's no sign there, it's assumed positive. So to move this whole term to the other side, we'd subtract 3x. Now if we subtract 3x on this side though, we'd end up with 2x minus 3x, which would leave us with a negative. I, in my math land, prefer to work smarter than harder. Negatives always mess with us, so why put ourselves in that predicament to have more negatives? Let's stop and look at the problem first of all, and maybe we can avoid some of those. So what I always do is I take the term with the smaller number in front and bring that term to the larger number. So instead of having my variables on the left side, I'm actually going to move them so that they're on the right side. Once again, this is a positive 2x because there's no sign in front, so I have to take away 2x, and whatever I do to one side, the equal sign, I do to the other side. We're moving the entire term. Whenever you move terms, we add or subtract. Notice the x is going with the number. That's the entire term, which is why we're not doing any division. The sign in front of the term goes with the term, so do not lose this negative by the 7. Remember, subtraction is adding a negative, so that 7 is really a negative 7. These are my like terms. They are like terms because they have the same variable to the same power. We can only add or subtract like terms. And when we add or subtract like terms, we add or subtract the big numbers in front, called coefficients, and leave the variables the same. If we're adding and subtracting because they're like, they're going to stay the same. So 3x minus 2x is 1x. Now when we have 1x, we usually don't write the 1, because 1 times anything is anything. Whew, that was a lot in there, wasn't it? You might want to rewind and listen to that one again. Okay? But 3x minus 2x is 1x. We don't usually put it in there. If you want to put it in there, that's fine. Here we bring down the plus 4 because that comes along for the ride. Now I have to get the term with my variable by itself and move the unlike term. Because I'm moving terms, we add or subtract. We do the opposite of what's happening to it. This is a positive 4, so I'm going to subtract 4. I'm moving the 4 because I want to get the x by itself. In order to do that, I just have to get rid of the number that's being added to it. So we subtract 4 there, subtract 4 there. This is a negative 7 and a negative 4. When we have same signs, that's when you add the numbers and keep the signs. Now you can write it like that. Negative 11 is the same thing as x. But if you do like to have your variable first, you can. Just be careful in writing it. X is equal to negative 11. Not a big deal in this case, but it would be if this was an inequality. The sign of your inequality, those are those greater than or less than symbols, less than or greater than symbol, we'd have to make sure that the open side is still towards the variable, if that's the way the problem was written. When you write it the other way. Okay? So in this segment, we had two terms with the variable term. Our first example, they were on the same side of the equal sign, so we just combined them as they were. In the second example, they were on opposite sides of the equal sign. So to move the terms, we had to do the opposite sign to get them together. And then we solved from there. Now, what's going to happen if we have some parentheses in? That is our next step in the next segment of week 3 video.